what you are interfacing? What are you interfacing? Keypad. You are interfacing a keypad, and we didn't write a program for a keypad. Okay, so we are interfacing a keypad, then we are using a switch. So if we say if test is equal to 55, so we will execute code 1. There may be multiple statements. Similarly, if this condition is false, it will jump on here. Then multiple statement for code 2. Then default, your default code, and then you will jump on exact code. And then there will be also some exact code. Exact. So this is a simple program. How we can write the code? So simple. So can we can again config org. We can start from org. Let's assume we start our program at $000. So we can how we can do it like this? Move. We are only interfacing what? Keypad. So move cr keypad. Okay. Hash input. First we have defined input. Hash input. Okay. Then we can then move. We have again wait. Move what? R4. We can use any register, maybe R1. You are using register R1, and then SR keypad. We have defined some SR keypad. Okay. Then compare R1 with what? Ready. We may have condition 0 for a ready or 1 for a ready. When it's not equal, then wait. If it's equal,
Scan.
okay, then scan. Okay, so now if you look at this portion, am I right?
Yes.
Okay, now we have scanned. Now we are also scan. So in scan we can move this. Move R2. We are using some other register R2. So DR keypad. So now we have finished this part, the scanner part. The scanner part is very simple. The same code that we did previously. So the same code. Now we are in the scan code. Now where is the test variable lying now? What is the destination of the test variable? R2. Actually, R2 is containing the content of the test. Okay, so it's containing the test. So what should now we have switch statement? When we have switch statement, so now we should compare what? R2. So compare. So actually, okay, I'll write it here. After here, the code will be from here to here. Now we will compare R2. R2 with what? Which addressing mode we will use? No. Immediate addressing mode. Because it's a constant value. It's a constant value. So actually we will use immediate addressing mode. Compare R2 with what? 55. Which condition we will use after compare? BEQ. Branch equal. If you remember, this is actually Q and this is actually P. It will compute the contents of Q and the contents of P. So actually, if it's a compare R2 with if R2 is equal to 55, branch equal. So branch equal code 1. What is code 1? Code 1 is actually a label, not subroutine. It's a label. So we can write this code 1 here. Code, maybe we write code 1 here. So maybe this code 1 consists of 10 instructions. Maybe I1 to I10. So code 1 will say I1, I2, I3 up to 10. There are 10 instructions. When it's done, then break. When it's break, it will not check this one. It will not check this one. It should jump directly on what? Exit. It will jump on the exit. So it should jump on the exit. So actually there should be one instruction: jump, exit. So it is conditional or unconditional? Unconditional. So maybe there is one label exit. So we are now defining one label exit. Okay, and then in exit, maybe on this exit code, maybe there are 10 instructions. Maybe there is I11 to I30, maybe I31 to I50, and maybe in exit code maybe I51. So actually the exit code starts from where? I51. Okay, so now compare out with this branch equal code 1. Code 1 come up here, jump exit. Agreed? Okay, now if this condition is false, false, so actually if this condition is false, then you will compare R2 with what? 55.
Greater than 55 coefficient.
We don't need this instruction. Why? Because comparison has been done. When the comparison has been done, what will it affect? It will change the flags. Which flags? NC, CV. The flag has already been changed. So you don't need a second redundant instruction. So you can directly use it. BGT code 2. And then we can define some label code 2. What is the first instruction of code 2? I11, I12 up to I30. BGT code 2. When this condition is false, then it should come on directly default. So it's actually default code. So the default code is here. Default. And how did it start? Which instruction? I31. Then I32 until I50. When this default code is done, where should it jump?
Exit.
Jump. Exit, and it will come on here. But after code 2, we are not using jump exit.
Automatically.
Because it will jump automatically on exit. Understood? So actually now we have studied, now in this case we have studied that how we can translate a small C program into an assembly. Now if you look at the memory map of this program, so actually this instruction has an address of 4000, 4004, 4008, 4000C, 4010, 4014, 18, 1C, 2024, and so forth, so on. Okay? Agreed? Okay. So now this is and then there are also some other examples. There are also some other examples that are found that can be found here. And now we have just changed a little bit the program. Okay, I maybe I will also right. This. Now if we say case case 65 code 1 break, case 75 code 2 break, Then case 55, code 3 break, then we have default code, and now we have exit code. The same. It's already done. The scan part is done. We have again test. Move RTTR, compare. Okay, now we are changing the code here. Now in the previous case, we are only comparing it with a single value. That was 55. That was the reason we are not using multiple instructions. So actually compare. So what we can do, compare R2 with what? 65. Then branch equal code 1. Then again compare R2 with 75. Branch equal code 2. Compare R2 with 5. Branch equal code 3. And in this case we will also use some code 3. But now when we have code 2, after code 2 you should jump on exit, so you need jump exit here. Okay, and now after code 3 you don't need an exit and jump. Okay, code 3 and now default code and then. Zero, and we want to find the greatest element of the array. So write an assembly language program for this.
Start with this.
Okay, so now we have a problem. We want to write an assembly language program. Assume that there are 200 elements in the array. There are 200 elements in the array. So this is the memory location. So this is element 0, element 1 and element 190. So there are how many elements? 200 element are stored in it. The base address is 4000. The starting address is 4000. So it is the first element, address of the first element. Assume that each element consists of 16 bits. So it means that the next address will be $4002. Okay, so now I already told you that if you want to access the elements of the array and you want to access all the elements of the array in a sequential manner, so you need an address register to point to the first element of the array. You need an address register to point to the first element of the array. So you need to initialize any address register. So when you want to initialize any address register, so let's assume that we have an address register A0. So now we are starting our program org $5000. No, now you are confused. The problem is this. This is the data. This is the data, and where this element 0 is stored, element 1 is stored. This is org 500. This is an instruction now. This is an instruction, this is the data. Maybe this element 0 is equal to 5, this value is equal to 9. Maybe this E2 is 4. So these are the elements of the array. This is a data, this is not instructions. And org 500, so now we have some main program. So now we always have a view of the memory which is an address 5000. Okay, now we need to initialize A0. So what should be the contents of A0? Move A0 hash, move A0 hash $4000. So this A0 is $4000 is now pointing to the first element of the array. And now this move instruction is stored at memory at which location? 500. So move is stored here. So this is an instruction and this is actually data. So there was a confusion here. So now we have initialized an address register. Okay. So we want to. So in the first case, We want to find the sum of all elements in register R7. So first we need to move this first element into R7. Move R7 A0 plus A0 plus. So actually, what will be moved into register R7? A0 is pointing to this location. This contents will be moved 5. Will be moved into which register? R7. So now at this point the contents of R7 will be 5. Okay, now we also need a loop counter. Count. So we can also have count equal. How many elements are there in the array? 200. Count equal 200. So now the first element has been moved. The first element has been moved. So we can decrement. Okay, now
ऐड करना भी है सर.
no. We also have this. We can also move R3 hash count. So the value of R7 is 5. The value of R3 is 200. It is actually a loop counter. It is actually a loop counter. So when is the first move into A0? So now we should decrement. Decrement what? Loop counter. Decrement R3 or R7? R3. Decrement R3. Okay. Now then we decrement R3. So this is the first value. Decrement R3. Okay, now what should we do now? No.
कंपेयर करेंगे सर.
Compare
R3 200.
R3 with 0. Now we are decrementing.
We are yes sir 200.
Okay. Where it is not equal. It is not equal. Branch not equal. We should do some addition. Addition. What? Add. So we have this add. Why add is necessary? Why add is necessary? We want to add the contents of R7 with what? A0. So we can have add. Okay, now maybe you do this add here and just for the sake of, I think so it's not the right way. Move R3 hash count. Move R7 hash 0. So initially what's the contents of R7? 0. Okay, now you have an addition. Add R7 A0 plus. So actually, so add initial contents was 0. You are using 0. A0 is pointing to this. What the value of R7 will be 5. Then you decrement R3. Decrement R3. So what is the new contents of R3?
199.
199. When it's not equal, then you again move to addition. And by that time, because you are using this array with post increment, to which address it is now pointing?
4004.
4004. What is the previous contents of R5? 5. What will be now new contents?
9.
5 plus 9. 14. Then what is the new contents? 98. Automatically it will move to the next one.
सर ये 8 R7 हम कर सकते हैं.
क्या कर सकते हैं? Why not? in C or even in MATLAB, can you write C is equal to C plus 3?
जी सर हाँ
Actually, it is the old value.
ठीक है सर
It's not mathematics, it's programming.
ठीक है सर
Actually, C is not equal to C plus 3. But in programming, it's valid because it's the new value and it's the old value. This is also valid in MATLAB, this is also valid in C and
Any
many programming languages. Okay? So actually this is also valid. This is also valid in SLB. Okay? So now we have not equal to addition. When it's done, at this point you can now display and which value you will display? R7. You display R7 and now it's your final value. Okay. So now this was the first program that you have you need to write. Okay. Now we have another the same program. Sum of all elements of the array. Now we want to find the greatest element of the array. G. Now you want to find the greatest element of the array. We will use the same methodology. We will use the same methodology, but a little bit different approach. They say it's move A0 count. This will be the same because A0 is now pointing to the first location. Then R3 count. Definitely we need a loop counter. Then
we can do
G. How will you do this? Move R3 count. G. The greatest element of the array and you want to move it into R7. Yes, we need to store the first value into R7. So we can do this like this move. We can do it like this. We can directly use move R7 A0. We are not incrementing. So now R7 will contain the first element. And what is the first element? 5. Compare R7 with A0. No, we are comparing. Now we need to compare this R7 with the next element. So compare R7 with A0 plus and 0. Compare R0 with A7 plus. Okay, now what we are comparing? We are comparing the second element. 9. If this second element is greater than 5. Now, okay, so now it is Q and P. Q and P. If Q is less than P, we need to do update. Yeah, we can say compare R7 with A0 plus BLS update. So now there is also some label update. Now, what is the contents of R7? 5. What is the contents of?
9.
No, but we need to do A0 plus again here. Because you are using a fluid addressing mode. Okay. And then I will explain this why I am doing like this. Move R7 A0 plus. The value, the first element 5 will be moved into R7. 5 will move into R7. A0 will now directly point to the next element. To the next element. So when it point to the next element, we need to first decrement. Decrement what? R3. Decrement R3. And if it is branch equal decrement R3 and compare. Now we will compare R3 with 0. Compare R3 with 0. When it's 0, just jump. Exit. So now exit will be somewhere else. We have done exit. Now we have only done the first element, not the second element. Okay. Now we will then again compare R7.
सर excuse me,
Yes.
जंप की जगह बी क्यों नहीं है?
Okay.
Branch.
Yes. You are good. Well, thank you very much. It is unconditional jump instruction. You should have updated me. Okay? Because compare R3 with 0, it is a conditional jump instruction, not unconditional. When it's conditional, so you need branch equal, exit. It will jump on the exit. Now we will compare R7 with A0 plus. Okay? And if it is BLS, if it is less than, we will move on, update. But if it is not less than, then it will jump, compare, and now this is an update. I will see that what the code should I do and compare. I will do this with an example. Okay. So now we should initialize these values in memory. Now let's assume the first value is 5, then 9, 5, 9 and 3. First value is 5, 9 and 3. Initially what will be the value of R7? 5. Move R0 S7 plus R7 is 5. Now A0 is now pointing to the second location. Right? Decrement R3, what is the value of R3 now? 199. Compare R3 with 0. R3 is not 0. This condition will be false. When this condition is false, then we will compare R7 with A0 plus. R7 is now compared with this 9. When R7 is compared with this 9, so actually BLS.
लेकिन सर हम ऊपर तो पहले इसको पॉइंट कर चुके, तो A0 प्लस होगा तो फिर A3 पे नहीं चला जाएगा?
No. A0 plus यहाँ पे है ना?
नीचे भी A0.
A0 plus first value will be accessed. So this R7 is now compared with 9. In A0 first the element is accessed and then it is incremented. So this actually, if you remember this register indirect post increment, first the element is accessed. Here we are using A0 plus. First the element is accessed. Which element is accessed? 5. When 5 is accessed, then the address register will point to this location. समझ आइए बेटा? ठीक है. Now in this case, compare R3 with 0, branch equal to exit. Compare R7 with A0 plus. So now we are comparing R7 with A0 plus. A0 pointing to this. Now we are comparing 5 with 9. Now this 5 is smaller than 9. We need to update it. We need to move this 9 into 5. So we should jump on the update. Now we will jump on the update. When we jump on the update, now in that case A0 is pointing to which location? 3. But what value we want to move? 9. So in 9 we are update. So we now move R7. We are updating R7. But then A0 no, not minus 2. We are using absolute addressing mode -2. So actually in this register indirect with absolute addressing mode, it will move this 9 to R7. So now the value will be 9.
Sir, 2
-2. We are using register indirect with displacement addressing. In register indirect with displacement addressing, the address register does not change. It will still point in here. It will still point here and it will -2. So actually we assume that the size of each data element is 2 byte. So it will access this 9. Okay, and this 9 will be moved into 7. And now address register will still point here. It will not be updated. If register indirect with pre-decrement or post-increment, the address register is updated. But register indirect with displacement, not updated. The option is positive or negative? negative. The offset is negative because we are accessing the top element. And the offset is only 2. Why 2? Because this address is 4004. That we are pointing to this location. So when it's done, when update is done, so we again will jump on compare. When we do the next iteration, compare, address register is now pointing to this. Now we are comparing 3 with 9. Now R3 will be 198. The condition is false. Compare R7 with 0. Compare R7. 9 with 3. Okay. This condition ls. It's not less than. The condition will be false. Then again jump on the. Okay. So now we have studied 2 iterations. In the first iteration, this element was smaller than the element in the array. Then it will jump on the update. And in the second iteration, this element was greater than that element. In this case, it will not jump on update. And when all the elements will be exhausted, when all the elements of the array will be exhausted, in that particular example, in that particular scenario, not example, in that particular scenario, the loop counter will be 0. When the loop counter is 0, and we have reached to the last element, when we are, it will jump on the. G, any question? Any question? Okay, good. So there are a lot of things. There are a lot of things that you need to consider that when you are writing to an assembly program. So